Okay, so let's continue what we were doing yesterday. I think yesterday we were just starting to get to these problems where we have to recognize a pattern. And then we have to try to figure out a rule. So we were actually looking at this problem right here. And we're looking at the first of these problems, part A. So let's get started right there. We had the numbers 2, 5, 7, wait, let me go back. 2, 5, oh, is 10 next? Okay, thanks for taking notes yesterday. And then, so 10, and then 17, right? And what we had to do was figure out the next number. Did we get the next number figured out?
Yeah.
We said 26, right? And one of the things we noticed was that this one was going up by 3, and then it's up by 5, and then this one was up by 7, and then this one's up by 9. And so we could easily predict this one because it's going up by 11. Alright, so we would say the next one after that one would be 37, right? Okay, so we did figure out the next term in the sequence. But now what we'd like to do is figure out what rule sort of works. And we're thinking that's going up by an odd amount each time. So an odd number you could write as 2n plus 1. That would make it an odd number. So if we tried this out, now here's the thing you have to realize, lots of times you have to guess. You make like an educated guess though, and you try it out and see if it's working. You see, so if n is equal to 1, what happens? If I try to find a sub 1, I would put in, let's see, I would put a 2 times a 1, I get plus 1, and this gives me 3. Well, the first term is supposed to be 2. So maybe I'm not supposed to add 1. Well, so then you can tinker with this. I mean, you can fool around with this. So what you do is you, and by the way, you can't give up so easy. These problems, you don't want to give up after 10 seconds, say I give up. That's not going to work. You're going to have to struggle a little bit to get these formulas. You might have to struggle for 10 or 15 minutes trying to get it. Don't give up. Are Vikings quitters? We're not quitters, are we? People in Japan don't give up until after an hour and a half of trying the problem. So that means we can try at least 2 hours before we give it, right? all right. You don't have to try as long as Chinese and Japanese and all these. But I would say try for at least 10 or 15 minutes before you give up. You might have to struggle on some of these. And you just keep guessing along and you say, okay, well, what's working, what's not working? What else can I try? And you just try things. All right, so we'll try this one. Well, okay, if we try 2n, well, let's try n equal to 1 again. Well, that would give me a sub 1, because n is equal to 1, so the 1 goes in here, the 1 goes in here, and so you get 2 times 1. Well, that does equal 2. And you go, bingo, we got the first one, right? But if you try a sub 2, does it work? Well, then you do 2 times 2, right? But that's equal to 4, and it's supposed to be 5. So a sub 2 is equal to 5. So clearly, we have the wrong formula. Now, I don't know how, yesterday when we were doing this, my other class, someone saw the formula right off the bat. They say, oh, it's n squared plus 1. N squared plus 1. Brilliant. Sometimes there's going to be some students that have a quick insight and they say they get it right off the bat. And other students will try it 15 minutes before they get the idea. It's n squared plus 1. Let's try it out. So they did get lucky. I agree. I was quite surprised. But every once in a while you'll have a brilliant moment and you go, hey, I figured it out quickly. So they said it was n squared plus 1. Well, let's try that out. So a sub 1 should be equal to 1 squared plus 1. Well, what is 1 squared? 1 squared is 1. Now 1 plus 1 is 2. So they got the first one, right? Looks good. Let's try the second one. The second one would be 2 squared plus 1. That's 2 squared is 4, right? And you add 1 to it, you get 5. Well, I got the second one. Well, the third one is supposed to be 10 though, right? So if you try a 3, that's going to be 3 squared plus 1. Well, 3 squared is 9 plus 1 is 10. So they've got it. I think they got it. Now let's check the fourth one. A sub 4 would be 4 squared plus 1. So they got 16 plus 1, 17. It's becoming very convincing that they got it, right? Let's just try the next one just to be clever and make sure. The fifth one would be what? It would be 5 squared plus 1. That's 25 plus 1, 26. And sure enough, that's it. So, for some of you, you may have thought of it real quick. Well, a student in 5th period that I had yesterday got it. I was quite surprised. They got it right off the bat. Sometimes they'll spend 10 minutes and not even get it. Some of these problems will be tricky and fussy and annoying. But one thing I want to do as a teacher is encourage you. Sometimes you got to go through the struggle before you get better at this. And you only get better with experience. Let's try another one. See if we can figure out the second sequence. Okay, this one I think is not as hard as the first one. It's negative 4, negative 8, negative 12, negative 16. So let's go back to our paper. Negative 4, negative 8, negative 12, negative 16. I'll bet a lot of you could already get it figured out. What's the next one? Negative 20, right? That one's easy. Okay, can we come up with the rule now? A sub n. What's the general rule? We're just taking 4. What are we doing? We're subtracting 4?
Right. Well, yes, since it's negative, we minus positive 4.
Okay, so how do we want to write this in? We want to write minus 4? What minus 4?
X minus 4.
Oh, I got
Try that. Now, this is a good, clever guess. I appreciate this. Now, don't be surprised if you get it wrong at first. We'll try it, and then we tinker with it. So, let's try it out. If n is equal to 1, then we'd have a sub 1 is equal to 1 minus 4, and that equals negative 3. So something's wrong. So now we say, well, what do we have to do to fix it? And so this is the natural process, my friends. Don't be surprised if you don't get it your first attempt.
Or is it n times negative 4?
Let's try that. N times negative 4. Now I like this. It's a refined, a new guess. So you said n times negative 4. Let's check it out. Much better guess than the previous one. So hopefully that's what happens. You get a little bit closer each time. So this time when n is equal to 1, we get 1 times negative 4. And that does equal negative 4. So that's always happy. You got the first one. So does it work for the next one? So n equal to 2. Well, that would give us a sub 2 is equal to 2 times negative 4, which does equal negative 8. And so we got the second one. But does it work for the third one? Okay, by the way, you should do at least 4 of these before you're convinced. Okay, so a sub 3 would be equal to 3 times negative 4. And I think you can see quickly that we've got it. Right? So the general rule, now by the way, normally we write numbers in front of the variable. So let me just rewrite this one. I'm going to say it's equal to the a sub n, the general rule, is equal to negative 4 times whatever n is. Now that's kind of handy because it may be that you want to know what the 20th one is. All you'd have to do is put in 20 here and put in 20 here. Now you know what the 20th term is. Now by the way, one of the things I told you yesterday is that you probably feel right now that this is nonsense. Why are we doing this? And I told you yesterday that these are formulas that build the financial formulas that you do in finance. Like when you have a loan. And in this case, instead of knowing the 20th number in the sequence, you'd want to know what's my 20th payment going to be on my loan, for example. Or what's the interest going to be on the 20th? You know? because businesses try to pay off their loans. They try to make their assets positive and all these other things. So there's all sorts of formulas. My friends, we're doing some of the baby work right now for the business formulas that we're going to get to. You get to those in pre-calculus though. So please understand what we're kind of doing now may seem like nonsense. But these are the formulas that give us the ones that we use in business calculus. The ones we use. And so you kind of have to start with the basics before you get to the bigger stuff. In any event, that was easy. So we got that one. But please trust me, some of these might take up to 15 minutes before you finally stumble on the right path. Just like Emmanuel here. We didn't get it the first try. And some of you guys might try 10 times before you get it. And some of you guys might be calling up your friends and say, what did you try? What did you get? And here's a couple other ones. Alright, let's see if we can get this one. Okay. So let me go to a clear sheet so we can see our work a little bit better. That one I think was starting off with -1, and then it was -8, and then it was -27, and then -64. What's the next one? Anyone recognize this one? Any guess? It's n cubed, but it's not quite n cubed. Negative n cubed. There you go. Take a look. He recognized these are the cube numbers, right? 1 cubed is equal to 1 times 1 times 1, which is equal to 1. 2 cubed, okay, is equal to 2 times 2 times 2, which is equal to 8. 3 cubed, okay, that's equal to 3 times 3, that bug's in there, 2 times 3, which is equal to 27. So these are those numbers. All we need to do is throw in a negative. So the a sub n on this one is equal to, or the general term, -n cubed. Does that make sense? So that one is actually not too bad as long as you're familiar with the cube numbers. Okay, let's go back and look at the second one. 0, 2, 6, 12. Okay, so this one, wow. We have 0, 2, 6, 12. We want to figure out what the next number is going to be. Oh, change the color. Should I use? Oh, turquoise. Okay, so let me just erase this real quick, and then we'll go to turquoise. All right, sorry. It's easy to see on my screen. So 0, 2, 6, 12. We want to figure out this one. Any ideas on this one? Huh? Is it 24? It might be. Convince me. Can you convince me? Why do you feel it's 24?
It's 21.
Oh, you think it? Can you tell me why you changed to 21?
No, it's not 21. It's 20.
Oh, are you just listening to Noel? So you think it's 20 now?
Yeah.
Noel thinks it's right. I think it's 21.
Because when you add them up, like,
Now hold up. Can you at least tell me your idea?
Yeah, so
guessing.
you know,
it was guessing.
Oh, you guys are guessing.
I'm an educated guy.
You guys, on this particular section, if that's the best you can do, that's better than nothing. Guessing is part of it.
Educated.
So what we're after, though, is what is a sub n going to be? What is the general idea? And so you might try something. How much did we jump here? 2. How much did we jump here? 4. How much did we jump here? 6. I think that is related to the pattern here. My guess is that we're going up by an even amount, and my guess is that we're jumping up by 8 on this one. So my guess is that it is 20. We might be wrong, but my guess is that it is 20. Now, if it is 20, we still need to come up with this general rule here. You remember when we had that other one that was going up by odd amounts? You remember it was going up by 3, 5, 7, and then 9 and 11? Well, this one's very similar. And that one, we had an n squared plus 1. Remember that? Based on our experience now, it might be conceivable that there's an n squared involved. Can we get that? Can we get that to work somehow?
If you have
Is there an n squared in there somehow?
-1, n squared minus 1.
Maybe.
N squared plus 2.
N squared. Okay, so let's try that out. We have some ideas. I want to go to a blank page now. We started out with what? 1?
0.
Oh, we started out with 0.
0,
2,
6, 8,
6,
8.
and then 12, wasn't it?
Yeah.
And then we said 20. Are they all positive?
Yeah.
They're all positive. So we're thinking that a sub n could be what? N squared maybe?
N squared
Plus
plus
2? Alright, well let's try that out. This is what you gotta do. You guys have to get over the idea of being wrong every once in a while. 'Cause you will be wrong sometimes, and sometimes you'll get it right. But let's see how we're doing. If n is equal to 1, then we have a sub 1 is equal to 1 squared plus 2, which is equal to 3. So we're not quite, we might be close. Let's see what happens when we do n2. Well, then we get a2 is equal to 2 squared plus 2. And that's equal to 4 plus 2. That's 6, actually. So maybe, oh, how do we do it in n equal to 3? When we do 3, we get a3 is equal to 3 squared plus 2. And that's equal to 9 plus 2. That's 11. We try n to the 4, we get a to the 4th is equal to 4 squared plus 2, and that's equal to 18. Well, this one was off by 1, this one's off by 2. You know, I have a feeling that we're pretty close, but we're not on it yet. Something's... Any other ideas? How can we tinker with this? What's another guess that we can do? This is where you refine your guess. This clearly is something's wrong with it. Maybe we could subtract instead. Should we take n squared and subtract 1? That's my guess. That would give us the first one anyways. N squared, let's try minus 1. You guys okay with that?
No.
Well, let's try it. At least give me a try. Okay, if n is equal to 1, we get a sub 1 is equal to 1 squared minus 1, which is equal to 0. So we did get the first term. Let's try n equal to 2. And then a sub 2 then would be equal to what? 2 squared minus 1, which is equal to 3. Loser. Oh, what a bozo. Alright, so maybe there's something else going on.
We do fractions on this, right?
You could do fractions. Now let me show you something else that might be going on. Maybe there's... This one's a little tricky. Okay. Maybe there's some other idea. Maybe it would be another 10 minutes before you stumbled on it. But let me show you something. Isn't this 0 times 1? And this 1 times 2? And this 2 times 3? And this 3 times 4? And this 4 times 5? Yeah? So can we guess the next one? 5 times 6? So we're going to say 30 there? You guys convinced this is the pattern? If that's the pattern, how do we write this then? In reference to this number right here, isn't that the same number? Isn't that the same? So this number is n, isn't it? In reference to this number, what's this one? Oh, now hold up. n in this case was equal to 1, right? N was equal to 1, right? So that's actually right here. There's n. This one is actually 1 less, isn't it? So let's write it this way. You see, this is a little tricky at first, but once I show you this little secret. So this one is n minus 1, I think, and then we're going to multiply that one by n. Does that make sense, what we did? You see, this one, n was equal to 1 here, right? So there's your 1, and then this one's 1 less. N is equal to 2 here, right? There's your n, and then there's 1 less. N is equal to 3 here, and so there's your n, and there's 1 less. So this looks like the pattern. Now, you could write the rule like this then if you want, or if you wanted to, you could multiply it out. So you'd end up with n squared minus n. Now, it is fascinating. There was an n squared involved. The problem was this. You see, so tinkering with this might take a while. So we did get it though. I'm convinced we have the general term. It's n minus 1 times n. Now, how long would that have taken you to come up with that? 3 days? An hour? 10 minutes? 2 minutes? I don't know. People will struggle trying to get these sometimes. And sometimes after 10, 15 minutes, you give up and move on to the next one. You come to class and say, Mr. Russell, I struggled with number whatever. Could you please help me get it? Because some of this takes experience. It's like anything. Once you start to see the little critters that come up, you start to become familiar with the critters, and then you've learned how to beat them, so to speak. I mean, right? You become familiar. Familiarity is part of the problem with this chapter. You're going to have to become familiar with some of these beasts, and then you won't find it so bad. Okay, so what I want you to do, I want you to do the first half of the assignment. Some of the latter problems will be the harder ones where you have to come up with those general formulas. And then tomorrow, Friday, we'll start doing part 2. What? The extra practice, you do the even ones, and you do sections 2-1, 2-2, 2-3, 2-4, 2-5. And stop. Just the even ones. Just do the even problems up through section 2.5. And you have to do it in my presence, so after school, before school would be good. Or lunch. If your teacher allows you to. But my pastime, we have a bunch of bozos in here. I don't want to. They're loud and I'm down. So my preference would be to come after school. But yeah. You guys take advantage. If you did bad, I will raise your... I don't care if you got a 0 on that test. If you come in and show me that you've worked out the problem, I'll raise your score to a C minus.
What did we have to do?
The even ones at the back in the extra practice, and you got to go through section 2.5. Now, by the way, if other people want to do it, I'll increase their score by 3 points. So this isn't for just the DNF students, it's for all students. If you want to improve your score, you do the extra practice, I'll improve your score by 3 points. That's a full letter grade. If you got a B on it, you can get an A on it. If you got a C, you can get a B. But you do have to do that assignment in my presence. Okay, so we're doing the first half of the assignment. Now you're going to staple it all together. We're going to turn it in as one assignment. So don't lose this.